Hey everyone, welcome back to Jeff Geo Academy YouTube channel. So today it's very cold here. So we are discussing about the magma, means melt of igneous rock that we call magma or lava. So basically in your mind a question may come, the how melt will crystallize. So the crystallization of the melt is the property of two things like density and viscosity. Here I have written properties of magma, nucleation and growth. So first we are discussing about the properties of magma. Okay, so the properties of magma, density and viscosity. Now what is the density? You know, density is the mass per unit volume, and viscosity is the resistance to flow, and the composition of magma, which is a magma evolved of a source region. Okay, the magma must evolve from a source region. Now the composition of magma is a function of temperature, pressure, degree of melting and phases involved. Okay, temperature and pressure you are know already, but what is the phase? Okay, what is the phase? So let us take an example. The phases are you know, the solid and liquid phase, solid phase and liquid phase and gaseous phase. The state is the phases. So I will deal this in very detail when I will go to the phase rule. Okay, you know the phase rule: P plus C, P plus C, P plus F is equal to C plus 2. This is the phase, degree of freedom, the components, and 2 is the constant quantity. Okay. So here the structure of silicate melt or magma. So this is basically determined by using the Raman spectroscopy. Okay, so you know the building block of is SiO4 tetrahedron. Okay, in the silicate melt we will found the SiO4 tetrahedron from low range to high, from low range order to high range order, means from isolated nesosilicate to framework silicate structure we will found. Now melt does not have long range order, having short range order. So it will not have long range order, not a big chain will form, very small chain will form, small range order. Okay. Now spectroscopic evidence suggests that a whole range of silicate group can be found in melt, from isolated tetrahedron to ring to chain. So I have told you in the previously that from isolated tetrahedron to ring type silicate, from tetrode silicates are also found, like olivine to quartz. Okay. Now as the SiO2 content of the melt will increase, the level of polymerization will also increase. The level of polymerization will also increase as the SiO2. It is obvious, when the SiO2 content will increase, it will polymerize and it will form polymers of SiO2, and the level of polymerization will gradually increase. So now I am going to talk about the physical properties of magma. So first, density. You know the density is denoted by the symbol rho. So rho is the mass per unit volume, means density will be equal to the mass per unit volume. So the density of lava is the ratio of the sum of the contribution of mass and volume. This is the ratio. Okay, ratio of the sum of the contribution of mass and volume from each of its component oxide. So mathematically, rho will be equal to summation of xi into mi divided by summation of xi gi bar. So this Vi will be is the molar volume, and molar volume will be equal to volume divided by number of moles, and here I is the fraction of I, Vi is the partial molar volume, and Mi is the molecular weight of I. So in a magma chamber, there are many components A, B, C and D, and all those components have different masses. Suppose M1, M2, M3 and M4, and accordingly these have also different volumes. Suppose D1, D2, D3, D4. So on adding all those volumes B1 plus B2 plus B3 plus B4 divided by M1 M2 plus M3 plus M4 divided by volume will give us the actual density of the magma. Okay. So this is all about the density of magma. Now the magma melt and density. What is the density of different magma melt? So if the magma melt is granite or rhyolite, then the density will be 2.6 to 2.7 gram per cc. Now if the melt is gabbroic or basaltic, then the density will be 2.9 to 3.0. Now the density of upper crust is 2.35, density of lower crust is 2.99, and the density of mantle is 3.3. Look, the density of mantle is highest here. Okay, and the lowest density here is 2.35 or 2.7. That is granitic, or the density of upper crust. Now, how the magma that is formed will rise upward. Okay. So the melt that is formed at a particular depth, it will form at a certain depth due to the melting of the source. From the source region will rise until it reaches a level of neutral buoyancy. That is the neutral buoyancy. Up to it reach the point that is called neutral buoyancy. That is the point where the density of magma will equal to the density of surrounding rock. Okay, so when the density of magma will equal to the density of the surrounding rock, then it will stop there. Okay, and up to that point, up to that particular point, the level of natural buoyancy, the magma will rise. Okay, upward. So I have illustrated this in the diagram. This is the density in the horizontal axis, and this is the depth in the vertical axis, and this is 0. This is the 0 density and 0 surface, 0 kilometer, and this is the 50 kilometer. So this thing I have in the broad line. This is the surrounding rock. So suppose this is the magma, and since the density of magma is higher as compared to that of surrounding rock, it will rise gradually up to this point. This point. This is the level of natural buoyancy, and it will stop here. Okay. Now, if some rock is there, then it will rise. This is the point of natural buoyancy or level of natural buoyancy, and this is the our source magma. It will rise up to this point. Now, since it will this is the density of the magma will be equal to the density of the surrounding rock, then it will stop here, and the entire magma will be stop here, and it will give rise to a magma chamber. So magma chamber will be located somewhere here. Okay, so the example is Yellowstone volcanoes. You know the Yellowstone volcanics in the USA, United States of America. So very beautiful volcanoes are seen there. You can search in the Google and see it. Very interesting volcanics and very beautiful they look like. Okay, so this is all about the how the magma will rise. So remember the thing that when the density of magma is greater than the density of the surrounding rock, it will rise upward, and it will until the point it reaches the level of natural buoyancy, it will stop there, and it will give rise to the magma chamber. The volatile content also play an important part in the upward movement of magma. So the volatile content of magma is also important. As the magma rises, the solubility of gases such as H2 and CO2 decreases. So when the magma will rise, the H2 and CO2 will be escaped with the formation of bubbles within the formation of bubbles, and as a result, the total density of magma decrease because H2 and CO2 part is escape out from the magma, and as a result of this, there is a decrease in the total density of the magma, and since the density is decreasing, it will make the magma to rise upward direction. Okay, so read the whole sentence. So the volatile content of magma is important. As the magma rises, the solubility of gases such as H2 and CO2 decreases with the formation of bubbles. Small bubbles will be there, and consequent decrease in the total magma density. There will be total decrease in the total density of the magma, and as a result, this drives the magma upward. Okay, clear out. So now this is the we are concluding here, and in the next lecture I will give a talk on the magma viscosity, which is also important, and the factors that affect the viscosity, and effect of water solubility on viscosity, and finally how the magma crystallize using the Gibbs rule. Okay, using the G equal to H minus Ts rule. And now I am giving you some quiz, 5 important questions that will be helpful for you. So now note down these important questions of quiz, and you can also send me the answer of the questions in my Telegram channel also. I will check it out. Okay, so first question is, what is the density of lava? Second is, how magma rise upward? Third is, what is Gibbs phase rule? Fourth one is, what is latent heat? And fifth one is, what is pyrolite? So now this is the end of the lecture. So stay tuned with the channel, and send the answer of the question in my Telegram channel, or you can also comment me. So if you have any confusion, then tell me in the comment box. Now thank you for your patience.